Okay, so earlier we were at page 138, and I said, well, 3, 4, 5, and 6, there's nothing much to do, so we just kind of skipped it. So let's kind of go back, and let's do examples 6, 7, and 8. So let's kind of look through those, right? Just to see kind of what we're talking about here.
139.
So example number 6. Example number 6, it says texting and driving. Santos, you're back. Read it for us.
The study of U.S. high school drivers was found that 3,785 texted while driving during the previous 30 days, and 4,720 did not text while driving during the same time period, based on data from texting while driving by Olson Schultz. Based on these results, if a high school driver is randomly selected, find the probability that he or she texted while driving during the previous 30 days.
All right, okay. So how are we going to do this?
We take them out of the
Huh?
total amount.
Well, do we know what the total amount is? Does it tell us?
Yes. Yes.
Yeah,
Gives us the ability to.
Oh, good, good, good. So it doesn't explicitly tell us, but we can figure it out, right? So how do we do that? We add the two. Is that what I'm hearing?
You have 300.
So we get 3, 7, 8, 5 plus what? 4, 7, 2, 0 over. How many of these texted? 3, 7, 8, 5. Is that what we're going to do? Does that make sense?
Yeah.
This is some weird stat. I mean, I can't believe this is true. This high? You guys, that's how much you guys text?
No, I don't know.
This does not make sense.
I would say like no.
I don't think that's sexual.
I am flabbergasted.
It mostly depends on the person.
Do you text while you're driving?
Oh.
It depends on the importance of the
Look,
person.
can I go? I don't call the office. So I could
Wait, what?
Huh?
Can I
Wait,
call the
what?
office and I leave?
I didn't get anything.
No, they're gonna have me called. I have really bad migraine, so yeah.
Okay, so let's go back. So this is how you're gonna figure this out, right? Are we good? You understand with this? So because the total sample space is these two, right? And then this is the amount of people who texted. Okay, all right. Again, this might not make sense. Anyway, example number 7. Thanksgiving Day. If a year is selected at random, find the probability that Thanksgiving Day in the United States will be on a Wednesday or a Thursday. So how often does Thanksgiving land on a Wednesday?
1/7.
What? What? When's the last time Thanksgiving was on Wednesday? It never happens on Wednesday, does it? It's always a Thursday.
Yeah, it's
It's always a Thursday.
It's like the third.
Danielle, wake up, okay? Thanksgiving is always a Thursday. So the probability that's going to land on a Wednesday is 0, right? Never
It's
happens.
always like the fourth Thursday in November.
What about on Thursday?
Oh, one.
100%, right? 100% on Thursday. Okay? All right. All right, let's flip the page.
I knew it.
Okay, so we sort of talked about this. We sort of talked about, remember when we were doing the boy-girl thing, we said, what was the probability at least one being a boy? And then we said instead of calculating all the ones about the boy, we would calculate the one that was no boys and subtract it from 1, right? That's what we call the complementary event, not a complementary. Complementary and complementary are different, right? Notice complementary here is complementary like this versus the one where you say the drink is complimentary. It's an I versus an E makes a difference here, okay? All right. So, definition, the complement of event A is denoted by A bar, okay? Okay, so in other words, probability of me rolling a 1 on a 6-sided die is what? 1 over 6. Okay, which means that the probability complementary of not rolling a 6 is 1 minus 1/6, 5 over 6. Correct? That's how you do complementary, okay? 1 minus the other one, right? So example number 8. Example 3 shows that in a recent year there were 3 million skydiving jumps and 21 of them resulted in death. Find the probability of not dying when you do a sky jump. So it would be pretty high, right? Hopefully it's pretty high, otherwise the skydiving or sky jumping is not going to have to do much business, right? So 21 out of 3 million. So this is how many times you're going to die. So not dying is 1 minus this, correct? Okay. Complementary, right?
That's where you should go skydiving.
Huh?
Go skydiving. You got the tools for it.
I think we gotta test it.
Well, I guess this. Okay. Blah, 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 okay. 4.1. So we're on page 141 now. Identifying significant results with probabilities and rare event rule for inferential statistics. Okay. Significant results. Significant meaning what? What was significance again? 5%, right? So anything that's less than 5% probability-wise is significant, right? Okay. All right. So significantly high and they're significantly low, obviously, right? So read those to yourselves. I'll give you about a minute or so. Go ahead and read those too. So what they're saying there really is what? So if your probability is greater than 0.95, it's significantly high, right? Because you're on 5% on the high end, right? If you are less than 0.05, you're on the low end of being significant, correct? All right? That's all that's saying right there, okay? Quickly do the probability review. There were 5 bullet points there. Okay, the probability of an event is a fraction or decimal number between 0 and 1. The probability of an impossible event is 0. Probability of an event that is certain to occur, that happens every single time, like Thanksgiving being on a Thursday, is 1, right? Notation, probability of event A happening and of A not happening, right? A bar, A bar, okay, all right? All right, we're good for today.